My name is Andy Roberts, and apparently I can't talk and click at the same time. Okay, there we go. So Jason, is that starting to come through?
Yep, that is coming through.
My name is Andy Roberts. I am a kind of a pre-sales architect on the data platform team here in New England, and so my job is essentially to go and talk to folks about data, as long as it has something to do with Microsoft. And that base of technology that has something to do with Microsoft has just grown leaps and bounds over the past few years. So my background, I was mostly a SQL Server guy. I started at Microsoft in 1998 as a consultant. So I was a consultant for about 12 years, working with customers to develop, mostly on the application development side around database, around SQL Server. So some, more on the websites, some data warehouse architectures, BI and reporting, kind of a little bit of everything. And then a few years ago, joined into more of our sales community, and really expanded from lately we're having conversations anywhere from SQL Server to big data landscapes with Hadoop, machine learning and analytics, data science process. Just the amount of stuff that touches data in both on-premises and in Azure is just astounding, really. And I'll tell you, if you asked me 10 years ago or 12 years ago whether I would be giving a talk and I would be actually showing Postgres or MySQL on my laptop in front of a worldwide audience, I would say you got to be kidding me. But obviously, as everyone has heard, we've really changed our stance on how we work with open source and technologies and competitive technologies, largely around Azure and what we're doing in that stack. So even if you look at SQL Server itself, you can see in the roadmap we've announced that we're supporting Python as a language inside of SQL. We opened up to R, and recently at Build we announced that we're going to be supporting PostreSQL and MySQL inside of Azure as a platform as a service. And so this is a little different than what we had before. So, if you looked at Azure a couple months ago, you could see virtual machine images, and they were running Linux, and they would have MySQL or PostgreSQL installed on them, and that was fine. But as you start to think about the difference, between infrastructure and platform as a service, the capabilities and the responsibilities that are taken on by Microsoft versus our customers is a little bit different. And so we'll talk about a little bit about that as part of the architecture. I've got a few talks coming up with this chapter. Jason has been nice enough to allow me to speak for a couple of topics, mostly about emerging technologies, about things that we're just bringing out into the market. I wanted to choose this one first, mainly because it's released, or at least available for public preview. So everything I'm showing you today, you can go out into Azure and do later this afternoon or along with me as we're talking through this. Some of the upcoming topics are a little bit further out, and so as we get to those, we'll talk a little bit more about the roadmap and our release cycle in Azure. And then lastly, I originally started to do this session thinking I'll cover MySQL and then I'll cover Postgres. But as I looked through a number of our use cases and our demos and our slides, I found out a lot of it's the same. So what I did is I took mostly what we're going to talk about is Postgres. I'll call out where I see some differences with MySQL, but for the most part, the architecture of this service and how we use the service is the same. So until you get to the client tools, when you start saying, am I going to connect with MySQL Workbench or Postgres Admin, everything else is very similar. So, just to level set, when we talk about a database as a service or a database platform service, what does that mean to us at Microsoft? And, to start with, we think about the global foundation of Azure, right? So Azure is 38 regions around the globe. We try and stay as consistent as we can with getting all of these services running in all of these regions. If any of the folks are on the line from some other countries, you might know that we do roll out on a schedule, so not everything is immediately available in all regions. So right now we'll be talking about MySQL and Postgres, which is available today in 11 of our 38 regions in preview. Usually the target is by the time we go generally available that we're close to all the regions, but there are occasional discrepancies. And then everything is built on top of the kind of storage and compute fabric that is in these regions. So if you look at in general just Azure storage, as I write into that storage infrastructure, everything is written 3 copies redundant storage in the local data center. Optionally, I can turn on replication on that storage and have multiple copies in a paired data center. So that gives me high availability and disaster recovery without having to really do much at the storage level. We think about disaster recovery a little bit more at the database level because we're database people and we make things harder on ourselves. But in general, when I write into storage, at least that data that's persistent to disks is available and is geo-redundant if I want it to be. Always redundant locally if I want it to be available remotely. And then we have a compute and service fabric. So this is all of the VMs that run inside of Azure run in this fabric. Where again, if I want to spin up say 4 VMs where I'm scaling out a solution, or 4 instances of a service where I'm scaling out compute or maintaining availability, as long as I tag that creation appropriately, saying I want all of these, I want this to be a kind of a high availability configuration, it's going to try and maintain separation between those compute resources. So make sure that if one piece of network gear goes out or one backplane on a server rack goes out, I'm not going to lose my entire service. I'll have minimal degradation, but as long as I've defined my service correctly, I'm not going to bring down my application, right? So Microsoft is managing that separation, that load balancing, that redistribution of applications. And then once you have that fabric in place, you start to be able to think about how do we build an RDBMS on top of that? And so now with say Azure SQL Database, that when you create a database, you're creating 3 copies of that. I'm maintaining essentially always-on availability groups across those databases, and I know that compute and service fabric is separating out my servers in an intelligent way. I have reliability in my storage infrastructure, etc. We're able to build out intelligent advisors, tuning, monitoring in a consistent way because we know that all of these servers are set up in a consistent, repeatable way. So now, if I turn something on for one server, I know it's going to work for any other server that I have in the environment. So today we've got in this platform as a service, we have SQL Data Warehouse, which is our MPP scale-out data warehouse built on top of SQL Server. We have SQL Server Database, which we all know and love. And as I mentioned in preview right now, we have MySQL and Postgres. So now, as I said, MySQL and Postgres now sit on top of this fabric that we built for the Microsoft native platform. So with that, so Azure Database for PostgreSQL is the same for MySQL, and we'll see this. We can provision this in minutes. It's either a few clicks or a few command lines, and boom, I've got a database built with high availability. It's getting backed up on the fly. I can change my performance tier, which is essentially changing either the amount of compute available to that server or the amount of storage available to that server without application downtime. So in many cases it's with no downtime, and in some cases it will be with a similar to an availability group failover, a small blip. Yeah, again, automatic backups and backup retention, point-in-time restore. And one thing I just said there, which is a little different from Azure SQL Database, for those that play with that, we're scaling compute and storage separately with this service. So that's true of both PostgreSQL and MySQL. And if you can read the tea leaves there, there might be other databases that would want to scale out storage and compute separately. Can't make any commitments to that. But. So if you think about Azure, at the top level, you have an Azure account. That's what is assigned to your company. And inside of that Azure, you've got multiple subscriptions. And subscriptions are generally used for separation of I've seen it in a couple of different ways. In some cases, I've seen subscriptions set up at a line of business level for larger enterprises. In some cases, I've seen it set up as a dev subscription versus a production subscription. It's just another way of kind of grouping and classifying resources. Also allows as a billing unit. So now I can receive bills or see spend at a subscription level. Underneath the subscription, we've got many resource groups, and a resource group is really a container of objects that I've deployed into Azure. Those could be networking resources, they could be virtual machines, databases, key vaults. There's a lot of different things. Hadoop clusters. Those are all things we would put inside of our resource group. Resource groups are a security boundary, and also a unit of I can tag a resource group as with a given project ID or a given environment ID, whether it's like dev or prod, so that I can apply appropriate rules to it, security to it, etc. So what are you deploying when you deploy an Azure database, either Postgres or SQL? I deploy a logical server, and then under that logical server I have a number of databases. And so that logical server is provisioned with compute and storage as I allocated it. And essentially at that point, I've got a connection endpoint. And what that means to us really is that may not equate to just I've got a VM that's running Postgres. It's that everything below that is going to be running on this database fabric that I'm not really responsible for managing. The important thing to me as a developer is that someone's listening on port 5432 for Postgres traffic at that server address, and they're meeting their SLAs for performance and availability and reliability of my service. I'm not concerned about whether I am striping across disks in a RAID 10 or RAID 5 configuration. I'm not concerned about whether I'm on EMC or NetApp storage, or I guess not EMC, Dell storage or NetApp storage. I'm really just concerned about that Microsoft is meeting that SLA for me, and I can run my application with no problems. And then the server is where we put that kind of the first level of the Azure database security boundary, and that's we'll call a firewall, a server level firewall. The server level firewall that we create for Postgres and MySQL works the same way as it does for Azure SQL Database. Essentially, it's an IP whitelist range. So I say that I want to allow connections from a given subnet or my workstation at that point in time if I'm working in a remote location, or a subnet that's defined in my company, and that will allow those services, services to connect to my database over that subnet. And Jason, if I'm not actively monitoring the chat window or anything, so if there are any questions that come up, please let me know, okay?
Yeah, actually, we do have two real quick.
Okay.
The first is the storage in the data centers of Azure, is that all SAN?
So the storage of the data center is, so first of all, it's a mix. There is solid state and spinning media available in Azure. It's not SAN storage as we know it. It's all software defined storage infrastructure. But it's not like if you think of like a Clarion box or Symmetrix box or something like that we have stood up. There's really just large volumes. Volume is meaning number of objects of physical disks that are running that we've defined mostly over like Windows storage spaces to come together to present storage to the end users.
All right.
So the answer is no.
Okay, yeah. And then the other one is, are the backups export dumps or are they database system backups?
So the backups that Azure takes are system backups. You know, like in SQL Server, it would be I issued a backup command. I'm still doing a little investigation on the Postgres and MySQL side on how I get at some of that information. I'll show you what I mean by that. But I can actually take a physical backup in Postgres that's using PG dump, but I don't know how to get at it yet. So that's something I'll have to follow up with on this group. And so those are just regular backups. If you look at Azure SQL Database, and that might be where the question comes from, we take a full database backup on a daily basis. We do transaction log backups throughout the day. Those are all stored. Those are all straight SQL Server backups, and we store those for 35 days, 14 or 35 days, depending on your service level. We have either, or we're opening soon, the ability to get at those database backups, I believe. So you can actually take that database backup out of Azure SQL DB, or at least so you can store them for longer term retention, essentially. The other way to get right now, the only way to get a database backup, kind of for your own use, is exporting to a backpack file. And I think in the MySQL and Postgres, it looks like I can actually take a database backup file, like a system backup, and copy that on premises. We store that in an on-premises server.
All right, sounds good. We got one other, but I think I'm gonna hold on that one until you talk a little bit more about the server.
Okay. So how do we create? So essentially, we say we want to create a server in a resource group which exists in a region. So U.S. West, U.S. East, West Europe, etc. That gets plugged into the database management service. Actually, I'm going to build this out. I communicate with the database management service in a couple of different ways. I can either use a command line interface. So we have something called the Azure CLI. I believe there will be PowerShell options for creating these resources as well. I can talk with the Azure portal. And if you want to write your own, you can write your own management API. We have some partners that are doing this for a lot of services. So if you wanted to have a standard way of building out, given architecture for maybe software that you're selling and want to run in Azure, you can write your own framework to build out and run those applications. But whatever you're doing, you're talking to the same set of REST APIs that run our resource manager. And then when you actually talk, so that's controlling the fabric, of the database. So I want to create a new server or multiple servers. I'm using that ARM Azure Resource Manager APIs to do that. I want to turn on and off this or add exceptions to the server level firewall. That's something you're doing it's external to Postgres or MySQL. It's really how that database operates with Azure, and that's what you're controlling with ARM. When you talk to the database itself, you're doing it with a native Postgres client, or MySQL client. So if you're using ptadmin for management of databases and tables and schema, that's the tool that you would use. If you're using MySQL Workbench, that's the tool you would use. If you're using Toad, and Toad, if Toad talks to Postgres and MySQL, the right versions, you could use that. Much like, it's very similar, again, going back to the Azure SQL database, I have got, PowerShell and Azure CLI and the Azure portal to talk about spinning up my logical SQL Server, adding my databases, etc. But when I want to communicate with that database, I'm using SQL Server Management Studio or Visual Studio or .NET or Java, etc. To talk at the actual database over TDS. Security in these services right now is it's native authentication only. I could see us trying to work with Azure Active Directory. That's speculation on my part. I don't have any knowledge there, but it would seem to make sense. I would say that the drawback is we're really working with native MySQL and Postgres, so we would need to get Azure authentication built into those products that we would then consume. But so right now, username and password authentication, SSL is connectivity. You can choose to accept SSL only connections. Server level firewall rules we talked about, so that's kind of IP whitelisting, and then much like transparent data encryption, you've got built-in encryption for the database itself, and then once you do that, backups get encrypted as well for long-term storage. So how do we actually think about how big of a server or how big of a database we're creating? We have something called performance tiers or service tiers. These tiers are the same for Postgres and MySQL. They'll look a little bit different than what you would see with Azure SQL Database, but it's the same principle. And so we've got basic, standard, and premium. If I look at basic and standard, I've got kind of the compute scale. I don't think we're calling it DTU, but it's a similar type of idea. Really, in this case, the compute scale comes down to really how much CPU are we dedicating to these servers, how much network throughput are we allowing, and then we have storage scaling from basic is 50 gigabytes to a terabyte, standards 125 to a terabyte, and then premium is up to 4 terabytes. The main I don't have the IOPS count here. I think and I'll have to pull these numbers up when I send the slides out, but I think basic is one IOP per gigabyte, standard is 2 IOPS per gigabyte, and then premium is between 4 and 10 IOPS per gigabyte. So the more you provision, the higher your IO throughput. So Postgres versions 9.5 and 9.6, and when we go through the portal, I'll show you the MySQL versions. So manageability, whether you're using any of these tiers, the manageability, the versions are the same. What's available today we're in preview, and the basic is what you have available today. So I'm going to go through these pretty quickly. These are 2 case studies. Really, what I wanted to get at was this is a company that is working with higher ed schools. They had an existing Postgres solution in Azure, but it was running Linux VMs and infrastructure as a service. their clients, the educators, the school systems would or the universities would put data into blob storage. They would process that in Postgres. They would put reports out in apps to the end users. Their front end and back end are a lot of technologies. As a Microsoft developer, I haven't had a lot of experience with. And the challenge for them was that they are now responsible for patching Linux. They're patching Postgres. They're managing their attached disks. That's not the business they want to be in. They want to be developing an application that's adding value to their customer, which is the universities. Anything that's taking away from that, for a startup, that's a drain on them. So with managed Postgres, they were able to number one, create the environment easily. They were able to use PGDub and import to actually move the data into that service, and then just get up and running. Connect the existing application to it, and they didn't have to make any changes. So it just worked. So that's again a little different between Azure SQL DB, especially as you looked at if you've been working with Azure SQL DB for a while. When we first came out with Azure SQL Database, there was a number of discrepancies in T-SQL and functionality between Azure SQL DB and what we saw in our on-premises or the IaaS version of SQL Server. With Postgres and MySQL, it is Postgres and MySQL. It's not a different flavor or something that we've dumbed down or taken something away from. It's that native service. Happy customer. So I'm just going to kind of go through. Again, another example of an architecture in Azure. So again, we're available in 11 regions today for the preview, and we'll see that open up over time. So as we get closer to service completion and eventually go GA, you'll see a lot more regions light up. I would imagine that most of the folks in this audience are somewhere in the U.S. and there's a few. So with that, I'm just going to jump over to a demo, and this is my Azure portal. And to start with, let's just go. We're just going to go and create. Go through the creation steps in the portal for MySQL or for Postgres and MySQL. First thing you need to do is find the template. You can navigate through databases and find the right one. Or if I say Postgres SQL Database, I think it shows up as the second one on the list if I do that. So this is the guy, Azure Database for PostgreSQL that we're talking about today. And then, for example, this web app on Linux with PostgreSQL. I think this one also, as it's tagged with preview, is also using this managed service behind the scenes. But for now, let's look at the Azure Database. The other guys, those are VMs. So if you look at PostgreSQL, as put up by Bitnami, Harden, put up by Cognizant, these are all Linux VMs with Postgres on it. There's nothing wrong with using that, but again, that infrastructure as a service where then you would be responsible for patching the VM, the Linux patches, the Postgres patches, etc. So if we look at, oops, I selected the wrong. After I talked through all that, I selected the wrong one. So Azure Database for Postgres. So it'll ask me for a server name. So we'll call this past Postgres Andy. We'll put this in a new resource group and give myself a username, password, I tell it what region I want to run in, and so you can see these are the, I'm going to have more, 1, 2, 3, 4, 5, 6, 7. I'll probably, yeah, so still about 11 regions. So I'm going to run in East US. We've got Postgres versions 9.6 and 9.5, and then it will ask me for a pricing tier. So as you can see, basic is available now. Standard and premium, as I mentioned, are coming soon. So I can, a number of compute units and then amount of storage. So if I said, the lowest tier, so I could start using the service at about $15 a month. If I wanted a basic tier with a terabyte of data or thereabouts, it's about $92 a month. So you can see how the storage costs change, as you hit the slider here. So we'll do smaller. I'm not going to generate more than 50 gigs in the next 20 minutes. And so I'm going to say pin to my dashboard. So when this gets finished creating, it will spin up my dashboard. While that's going, I'm just going to go ahead and fire up a new MySQL database. So again, you can see Azure Database for MySQL. This is the one that we're looking at, publisher Microsoft. So create. I'll use an existing resource group. And this is really the boring part of the demo because it looks exactly like the other create. So you can see I've got same regions. I'm going to US East because I think that's where I created my resource group. Versions of MySQL we're supporting are 5.7 and 5.6. And then pricing tier, similar story. I've got basic today, standard and premium, scale the compute and storage. Click OK. What I'm going to do a little different here is I'm just going to go over to automation options. So if I click on automation options, this might not work today. We'll see what happens. Okay, good. This is the ARM template for creating my service. So you can see that capturing the various parameters that I put into that template for service creation. And what it allows me to do is and then here's another view, the actual variable, the values I put in for those parameters. Everything except for my highly secure password, which was not null, by the way, in case anyone's wondering. And then the CLI code, or command line interface, or PowerShell code, or .NET code to deploy this service through the ARM template. It seems to be hanging on me. So again, here would be the PowerShell code to deploy my MySQL database as I just defined it. You can see it's pointing to a template file, a parameters file. It's got the appropriate functions to log into my Azure subscription and new Azure RM resource group deployment. So this deploys the resource group, and then it's going to apply the template file that I just specified with the parameter file that I specified. So it's, that's kind of the standard way of deploying these ARM templates into Azure. The other way is Azure CLI. So Azure command line interface, I can download for multiple OSs. So there is an Azure CLI for Windows. We call it the cross-platform CLI. It also works in Linux and on the Mac. In the Azure portal, I don't know if anyone has seen this in their portal show up yet, but there's a new icon up here called Cloud Shell. So if I click on Cloud Shell, it launches up to where I was before. Hopefully. And if it doesn't, I will just reboot the shell. Yeah, okay, there we go. I was almost too impatient. So I'm not sure if I'm still logged in. But I'll go through that. So the first line that you would execute is AZ login. I'm going to skip that. Go to So the first thing you do is you set the subscription you want to use. In many of your cases, you only have one subscription that's assigned to you. For me, I've got a couple of different subscriptions that I use for different projects. So I'm setting this one to one of them. The next thing I'll do is I'll create a resource group. And then lastly, I'll just execute the code to create a Postgres server. I'm just going to change this to my notepad file here. Call this pass handy 2. So in this case, it's great. So you can look at this command. It says AZ for Azure. Postgres means I'm controlling the Postgres services. I want to create a new server. The resource group is going to be pass handy 2, the one that I just created. The name of my server, location, username, password, performance tier, compute units, and version. So really all of the same options. I didn't specify storage size, so it'll take the default storage size, but everything else that I just specified in the template. So a very consistent interface, just a different way to script things out or automate things. So we go into, you can see I've got a couple of deployments succeeded. Just the one, because all I did was create the Postgres one. And then lastly, I just want to show, connecting into one of these servers. So, well, actually, on my dashboard, I've got my Postgres Andy that was created. It's going to give you some basic information about the server itself. Clicked one too many times here because it's pulling up a new screen. My browser is not liking me today, so let me go back to the dashboard. Try this one more time. And so again, what you're looking at when you're thinking about these services in Azure, you're thinking about how Azure integrates with things at a service level, not so much inside the database or inside the server, but how that resource interacts with Azure, right? So Azure knows that it sits inside of a resource group. Azure, because of what we've Azure knows the login name for the admin user because we specified that at the create, and we know that there's an API that we can reset that admin password. Azure knows how the resources that the service is using as it works with Azure, mainly CPU, storage, and network throughput. Right, that's what it really monitors in terms of its interaction with the service. What it doesn't know about is individual tables or objects that you're creating inside the database. If you look at Azure SQL DB, we've probed in there a little bit more deeply, right? So we're actually able to look at the query store and look at active query plans and perform intelligent optimization. Some of that might be coming soon with Postgres and MySQL. I think we'll have to see how the service is utilized and whether that is something that can be done in the same management plane as we did with SQL Server. I'm definitely not a Postgres expert, so I don't know the differences in tuning between Postgres and MySQL and SQL Server. Some databases that are created in the server. This is actually one that I created a little bit earlier, so I've got another database called NDDB. So it knows that the databases exist, but I don't really have any information into what's in them. I have connection security tab is an important one to remember. So whenever you create the server, the first thing you'll need to do is open up some IP addresses that are allowed to use the server. Because I am a lazy DBA, I have said that all IP addresses can access my server, mainly because I know I'm going to delete it in about half an hour. So, I'm opening up from 0000 to 255, all. Or, what you typically do is you would say, if I'm working from a remote location, I can say add my IP address, and I'm going to connect to that. The other thing you could do is if I knew that I was always connecting from an office that ran on a certain subnet, I could open that subnet up. Again, the same way that you would do with Azure SQL Database if you used that. I'll discard those settings. If I go to connection strings, this is just how we connect to it from the various clients. So ADO.NET, PHP, Python, etc. And then server parameters. This is where we have a little insight into the server itself. So we can set Postgres level server parameters. And we have the same thing for MySQL as well. So, how do we handle nulls? How do we, don't know what all of these means in Postgres context, but so it looks really, very, very much like, SP configure in SQL Server, exposed through the portal here. I can view my pricing tier when the service goes GA, I'll be able to change between basic, standard, premium. I'll be able to change the allocated storage, etc. In this case, you can say if I went from 100 to you, what would be the price change? We can't make these changes in the preview mode. Monitoring server properties, and then finally, it's how do I connect into the server itself? So if I look at Postgres DB, you can, PG admin. So I just downloaded PG admin onto my laptop. I had a little trouble downloading MySQL Workbench, so I couldn't show that today. But really, I just said I want to connect to a server. So I'll create a new server, which is really just a server connection object, and I'll call this. What did I call this? Andy Postgres. Well, I'll show you the connection strings, and I'll connect to my own. So you get the host name. So this is the name that we specified on the server name. So actually, if you go to the existing server, so let me open that up actually here. So Postgres Andy is what I used. So the server name is past Postgres Andy dot. The important part, postgres.database.azure.com. So this is your fully qualified name that you'll need to connect to. Uh, 5432 is a default port. The maintenance database. The username, so I'm going to say Andy Rob at pass Postgres Andy. I'm sorry, it'll tell me if I'm wrong, at Postgres. Save the password, and then if I say save, I never opened up the firewall rules for that server. So at any rate, that's what you would send in for your connection string. You can see I did this over here for the server I created this morning. To properties on that connection. So this was Postgres pass.postgres.database.windows. Azure.com 5432, and then I'm sorry, it's username at, and then the server name Postgres pass will get you into the default database. If you want to connect to a specific database, you would say Andy Rob at that database, and that gives you that user that connection information. And then from PG admin, I can do just what I would normally do through PG admin. I can look at what are the transactions going on the server, basic I/O statistics. I can create tables, etc. So if you're using PG admin, or if you were using the Postgres command line tools or what have you, you just have a Postgres connection now, so you have that same functionality. And again, very similar between Postgres and MySQL. I think we did talk a little bit about managed instances for SQL Server. We'll see a similar pattern with managed instances, which is one of the topics that we have coming up. That's something that was announced recently at I believe at Build as well. So that's what I have. I think we're coming up to about time. Jason, any questions in the list or any closing comments you want to make?
Yeah, we've got a couple questions here. How is the adoption for Azure Database for Postgres and MySQL looking like so far, and how is the pricing? Which I think since these are just coming out, there probably isn't much detail on.
Yeah, not a lot of detail on uptake yet. I mean, these just came out in the public preview. We have had very good reception in the user communities we've talked to. And you can see a couple, when I set up the slides, you'll see a couple of the case studies that are out there of people that have done this to date. But like I said, it's a new service. In terms of the pricing, we covered that a little bit on the server create. So you can actually see if you look at the video or if you want to create a new one in your own portal, when you go through the create database step in the blade, when I was selecting my performance tier and my storage tier, I was able to, it actually showed pricing for that database service. So in the case of standard, it's somewhere in the $15 to $100 a month range. When you get into the premium tiers and you're looking at solid state storage, that's going to be higher. But I don't know what we're going to spec up for the pricing yet.
Okay, great. And I think you kind of covered this one. I kind of missed if you did, but does the firewall rule setting modify the PG HBA configuration file in the backend?
It doesn't, as far as I know. So it's really the firewall rule is applied before you get into the database service itself. So that's applied at kind of the front door, at the fabric layer before I get into a connection to PostreSQL. One thing you can see a lot of times with Azure SQL Database is if the firewall is not set, firewall rule is not set, you'll get a specific error message saying the firewall rule isn't set correctly. If your and then once you set that, if your login isn't correct, so it's trying to set that before it gets to the login, which didn't actually answer that question. But I do not believe it's setting at the Postgres config file level.
All right, sounds great. Well, those are all the questions we have today, Andy. Thanks a lot for presenting, and thank you everyone for attending the session. And I think with that, I'm going to close things up for today, and we'll see everyone next time.
All right, thank you very much, everybody. Appreciate your time.
Thank you.